Ever wondered how your phone's voice assistant understands your commands or how your email filters spam? That's machine learning at work. It's a fascinating world where computers learn from experience, much like humans do. It's a form of artificial intelligence that allows machines to improve their performance over time, without being explicitly programmed to do so. Think about it. When you're shopping online and the website suggests products you might like, that's machine learning. When your social media feed shows you posts based on your interests, again, machine learning. It's quietly woven into the fabric of our everyday lives, making things easier, more efficient, and sometimes even more fun. Its influence doesn't stop there. It's reshaping industries, driving innovations in healthcare, finance, transportation, and more. It's the power behind the scenes, changing the world as we know it. So, if machine learning is such a critical part of our lives, how did it come to be? Take a step back in time to the mid-20th century, when the foundation of machine learning was laid. Our journey begins with a man named Alan Turing, a mathematician and computer scientist who dared to dream of a learning machine. In 1950, Turing proposed a concept. What if machines could learn from experience, just like humans? This theoretical machine would be capable of improving its performance by adapting to its environment, a concept that was revolutionary at the time. Just 6 years later, in 1956, the term artificial intelligence was coined at the Dartmouth Conference. It was here that a group of scientists, including John McCarthy, Marvin Minsky, and Claude Shannon, gathered to discuss the potential of machines that could mimic human intelligence. They believed in the possibility of creating machines that could understand, learn, and even improve themselves. This was the first time the world was introduced to the concept of machine learning, a subset of artificial intelligence. The late 1950s saw researchers exploring machine learning with fervor. They created algorithms that allowed machines to learn from data, making decisions and predictions based on patterns and trends. These early algorithms were simplistic, but they paved the way for the complex systems we have today. However, machine learning wasn't an instant success. It faced numerous challenges and skepticism, with many questioning the practicality and ethics of creating intelligent machines. It was a period of trial and error, of failures and small victories, but each setback only fueled the determination of these pioneering researchers, pushing them to refine their algorithms and improve their models. This was an era of exploration and discovery, a time when the boundaries of technology were being pushed and reshaped. The seeds of machine learning were planted, and though they were yet to fully bloom, the groundwork had been laid. The late 1950s marked the beginning of an era, but the best was yet to come. As we move into the 60s and 70s, machine learning started to take shape. This era witnessed the birth of key methodologies that would become the foundation for future developments. Let's dive in and explore this exciting period. One of the significant breakthroughs in the era was the invention of decision tree algorithms. These algorithms, like ID3 and CART, were like digital detectives, sifting through data and making decisions based on specific criteria. They offer a simple yet effective way of making sense of complex data by breaking it down into smaller, more manageable pieces. It was a bit like a game of 20 questions, with each query designed to bring us closer to the answer. Around the same time, the nearest neighbor method was also making waves. This technique is a type of instance-based learning where the function is approximated locally, and all computation is deferred until function evaluation. Simply put, it's a way of classifying objects based on the most common class among their neighbors. It's a bit like moving into a new neighborhood and adopting the habits and customs of those around you. The 60s and 70s also saw the emergence of reinforcement learning, where machines learn by trial and error. They were designed to make a series of decisions, receiving feedback, rewards, or penalties along the way. This feedback helped them to adjust their future actions. It's like learning to ride a bike. You keep adjusting until you find the right balance. Moreover, this period marked a significant shift in approach, from knowledge-driven to data-driven. Earlier, machines learned from pre-programmed instructions, but now they could learn from data and improve their performance. It was like shifting from learning by rote to learning by experience. The 60s and 70s brought significant advancements, but the golden age of machine learning was still on the horizon. As we entered the 80s and 90s, machine learning started to explode. It was during these pivotal decades that breakthroughs in technology and algorithm design began to set the stage for the machine learning we know today. One key development was the technique of backpropagation for training neural networks. This algorithm, a cornerstone of modern machine learning, made it possible for neural networks to learn from their mistakes, adjusting their internal parameters to improve future performance. It was like giving the machine a teacher, guiding it towards the right answers. Backpropagation was a game changer, opening the door to more complex and efficient learning models. At the same time, the 80s and 90s saw the emergence of support vector machines or SVMs. These models, with their ability to handle large amounts of high-dimensional data, were particularly well-suited to the growing volumes of digital information being produced. With SVMs, machine learning took a leap forward, becoming a powerful tool for data analysis and prediction. Another significant development during this period was the rise of Bayesian networks. These probabilistic graphical models offered a way to represent and reason about uncertain knowledge, bringing a new level of sophistication to machine learning. Bayesian networks allowed machines to handle uncertainty, learn from incomplete data, and make predictions in a wide range of fields, from medical diagnosis to natural language processing. Meanwhile, the increasing use of machine learning in practical applications started to become evident. From voice recognition in our phones to recommendation systems on our favorite shopping sites, machine learning began to quietly infiltrate everyday life. It was no longer a theoretical field confined to academia. Machine learning was becoming a practical solution to real-world problems. The 80s and 90s truly marked the start of the machine learning revolution, a revolution that continues to this day. These decades laid the groundwork for the innovative applications of machine learning we see now and set the stage for the exciting developments yet to come. Fast forward to the 21st century, the era of deep learning and big data. The digital age has seen an explosion of data, with every click, swipe, and keystroke contributing to an ever-growing mountain of information. This wealth of data has fueled a revolution in machine learning, allowing us to unearth patterns and insights that were once hidden in plain sight. Deep learning, a subset of machine learning, has been a game changer. It's a technique that teaches machines to do what comes naturally to humans, learn by example. It uses artificial neural networks with several layers. These are the so-called deep structures that inspired the name. Deep learning models can identify patterns in data and provide insights, making it incredibly valuable in a variety of sectors. And speaking of sectors, machine learning's influence isn't limited to just one or two. It's making waves in healthcare, finance, entertainment, and more. In healthcare, algorithms can now detect diseases in their early stages, potentially saving lives. In finance, machine learning is used to detect fraudulent transactions and automate trading. And in the entertainment industry, it's being used to recommend content based on a user's preferences and viewing history. But that's not all. The development of cutting-edge techniques like convolutional neural networks, built to process images, and recurrent neural networks designed to handle sequential data, has opened up even more possibilities. From self-driving cars that can see and respond to their environment, to virtual assistants that can understand and generate natural language, these techniques are pushing the boundaries of what's possible with machine learning. Today, machine learning is at the forefront of technological advancement, shaping the world in ways we could only dream of a few decades ago. It's an exciting time to be alive as we witness machines learning, growing and evolving right before our eyes. So, we've journeyed from the humble beginnings of machine learning to its current prominence in the digital era. We've seen how it evolved from basic algorithms in the 60s and 70s to becoming a dominant force in the technological boom of the 80s and 90s. In the modern era, machine learning has become an integral part of our digital lives, transforming the way we work, play, and interact. Peering into the future, the potential of machine learning is vast and thrilling. We envision advanced AI capable of mimicking human intelligence, making decisions, and learning from experience. Alongside this progress, we must also grapple with ethical considerations, ensuring that our AI systems are fair, transparent, and responsible. Moreover, machine learning could play a pivotal role in solving global challenges, from climate change to healthcare. As we continue to innovate and push the boundaries